So today I'm going to talk about Wind River, Linux, and the containers. So what I'm going to present is, it applies as well to Yocto, standard Yocto. But Wind River Linux is based on Yoctos, and I will use Wind River Linux. And I have the idea to avoid as many slides as possible. That's why you will see me instead writing a lot in the consoles and using Emacs, etc. So here I am using Tmax. No, it's not Tmax. It's what's it called? I forgot the name. Anyhow, use my Telnet console to get access to my build machine, which is located in Stockholm, and it has many more cores and then my laptop, and that's why I'm using it, and SSD disks, etc. And what I will be using our CD release. So Wind River Linux used to be released once per year, the major version, and then we have RCPLs coming out with different cadence depending on how old version you're using. But in this case, I'm using the CD version, which is a new thing that is delivered or updated every third week. And if I look at what I have here, so it's Git repository. It's going to paste from another window here. So this is a perfect way to look at what is going on right now. So this will eventually become the LTS release, the long-term supported release. And here we can play around with some new things. Mine is not that updated. It's from January, as you see. I thought I was going to update this morning, but then I thought maybe wait until I done this session. So this is, it could be called Wind River Linux 19 plus something, because this is newer than 19. And as I said, I will do containers. I have already built on this machine, and this is to avoid you for sitting just waiting for the builds to run. So things will be cached. So I start by running the environment variable. If you do cat here on the README, you can see that I set up, not that line, this line here. I set up to run generic x86, and I set this up to use a mirror that I have on the same server. So I'm not going directly. I have not downloaded everything to my project here. I'm using the mirror instead. And that's super important. But the first thing I will do is create a systemd container or system container. The difference between containers is, I mean, some containers you just want to run one application, and then you want just to start that application. In some containers, you're basically running like a VM, but you replace the kernel. You're using the CAS, the container as a service system kernel, and you have a complete systemd and a lot of processes running in your container. I'll call that more a system container. And that's those are pretty much much bigger things than application containers. Of course, depends on the size of the container. So I have this build directory now, and I will use the Wind River systemd container. I will just copy here from my sheet. So there is a recipe here that we have created. It's very simple. I will just do less on this one. It basically has a few variables: Wind River systemd container disable services, Wind River systemd container enable services. So this you can use in your local.conf to enable and disable services you want in your container. And as you see, it inherits this Wind River systemd container class. You can have a very quick look at that one as well. It looks like this. It's not much. So it does some settings. It changed the FS type to tar BC2 compressed and some other things. We don't need to go into the details. Let's see. Just bring up here, see if you have any questions. And then we're gonna look in my conf file, local.conf. If I go down here, so the only thing I added to the default file is these 4 lines. The WinRiver template to use feature dummy kernel. This means that I will not build the kernel. It will significantly reduce the build time. And then I will use this WinRiver systemd container apps variable and enable services and disable services. So I will use the Apache2 HTTPD service. That one I want to run in my systemd container. And then I will enable this one. And just for your sake to show that you can disable services as well, I've disabled 2 of the services just for fun. So that is all I've done. That's all I've done with this default script. And then I will copy. I don't need to copy everything, but this is the command: bitbake WinRiver system container. Press enter. So as I said, I've already built this before, so it will not take that long time. It will just look at my cached things, and you will see the result very soon. Okay, so now it's ready. Nothing happened really because everything is already done. I look in my deploy directory images. Here. This is the result of the build. And as you can see, I have a 28 meg here of a root file system compressed. So this is my systemd container for the Apache2. And this one I will use. So I have copied this to a shared area, which I then get access to for my virtual machine, which I'm running my Linux development on. As I'm running a Windows machine here, because it's easier with the company standards with Outlook, etc. But I'm doing development, I'm using this machine instead. So if I'm here in share, I've actually put already this systemd container here. This is the one that you see here. It's the same file. And I will import this using Docker. So I will use Docker throughout this exercise. The reason why it's simple to use, Docker is good for this kind of simple environments. It's actually not recommended if you want something in the production. I will come to that later. But so I'm doing Docker import. I'm doing import on this root file system, and I will call it WinRiver systemd container. Okay, I do the import. Hopefully it will complete soon. Like that. If I do Docker images, I should prone all my stuff first. I've used this machine for other things before. Make it easier for you to understand what I'm doing. Okay, let's do the import again. So now I just killed all Docker stuff I had in my system, so it will be clean. Redo the import. So write Docker images now. See, I just have one image, 96.7 megabytes. It was 23 if I remember correctly, compressed 28. And let's see if you can run this container. So I will use the docker run command like this, docker run and then I will keep it running. I will have it privileged. Name is Wind River systemd. That's the name of the container. I will use the Wind River systemd container image. And the command I want to run, the entry point in the container is sbin init, as it is systemd. So now I run it. I can increase the window a little bit. Okay, so hopefully this container is running. Yeah, it seems to be up and running. I open Firefox here because I will just make sure it works. So this container has an IP address right now. Docker has given it an IP address. And in order to find out which one, I do docker inspect Wind River systemd. That's the name of my container. And you can see the address here. I picked that one. It works. So my container is up and running, which is good. Proves that everything works. Copy. I will copy another line here. So this line here, I do an execute into this same container using bash and then an echo. I will change this message. I'm actually overwriting the index.html file, the default file. So if I do a refresh now, it will say systemd container. It was what I wrote here. Okay. We can also go into this container. And then the name of the container is systemd, and then I'll do a bin bash. So now I'm in the container context. In here, I can look at the services because this is a system container with systemd. It has services running. And you can see here, my service is running, it's actively running. And if you remember in my script, I disabled two services. It was this emergency service and audit. You see they are masked here. I can show you again my Emacs file. Audit service, emergency service. So I explicitly said to the system that it should disable these, mask them. Any questions? No? Perfect. So what I've done now, this is very much like a common image, like you would boot on a normal system. The difference is that it does not contain a kernel. It's very minimalistic as well. I don't have a lot of applications or packages that I don't need. And of course, you can remove even more packages. And now what I will do is an application container instead. It will not contain systemd. So, but I will do the same thing. I will still use Apache 2 HTTPD service or daemon. But instead, I will use it as an application container. So I'm going back. I have another build directory for my app container. Just for keeping it simple. Oh, no, it was something else. So what do I have in this? Let's see, conf local. See what I have in my local.conf here instead. So again, dummy kernel. It's just to remove the dummy kernels. I don't need to use it. Build it, sorry. And then I have this app container instead. And I define Apache 2. I will not go through here the script like I did with the systemd container, but it looks very similar. And then it's just to build bitbake Wind River app container. And it has I already built this once. It shouldn't, nothing should happen. And then when I've done this, I want to also do the same thing like I did with the systemd container. I want to load that in my development machine using Docker. Again, we can look at the result. deploy images. Okay, so now we have a wrong command. So now we have a 24 meg root file system compressed. Little, not that big as the other one, but it's not much less. It's not much smaller, I should say. This image I also have in my shared here. So it's this one, and I will do like I did before. I will import this one. So let's import it to Docker. I will call this Wind River app container instead, to distinguish from the systemd container. I do Docker PS now. Oh, I don't have it, of course. I just imported the image. If I do Docker images, then I will see the image. I just imported it. And then I will run a container with this image. And this is my command line argument. So it's very similar to the other one. So yes, I will use Wind River app container, and I will use user sbin httpd, and then some arguments, same arguments as the service is doing when it's running the systemd container. And just press enter here. Docker PS, it's up and running, perfect. Again, I will do inspect on Wind River app container. And that was the image. So I can do inspect in Docker on anything. So I did inspect on the image instead of the container I just loaded. Copy that. So it's similar address. It works, it says here. But again, let's change the message so we can distinguish the two. Maybe I should say what I did here. Execute bash command echo to this index file.html, and it should say Wind River app container instead. So let's do refresh here. Yes, it works. I can go back and look at my 02. This has systemd container. If you would have this in a real system, of course, it will map the ports to something else instead, like I'm doing right now. Any questions to this? No?
Hi, just a small question. Is this fully related to the containers and stuff?
How do you mean? I mean, yeah, we are building containers right now.
Okay.
So a container.
Okay.
Yeah, go ahead.
Please continue.
Yeah, no. So I mean, a container. What the container actually is, it's a tarball, so to say, of the root file system and some meta information. That is what the container is, according to OCI specification. And what I'm doing right now, I'm building tar bz2 files, right? What I don't have in the system is the meta information, but that I do when I do the Docker import. So these are real container images, yes. The funny thing, I mean, a container is not that more than this. And then it's up to the container runtime, the container engine. I'm using Docker right now to set up everything, how this container works. Did it answer your question?
Yep.
Yeah. So, I mean, the easiest way to build a container, if you do an image before, is to just take the image, remove the kernel, and then you have something which looks like a container, but it's not really what is the meaning of cloud native when people are doing this cloud native doing containers. The cloud native also often mean that you try to minimize the container to only contain the exact application that you want to run. But so what I did right now, I used httpd, right? That was my container that I created with Wind River Linux. I could say Yocto. Now I go into Docker Hub. If you go to Docker Hub, you can actually find already made containers for you. And there is a HTTPD container, official one, official from Docker, that is. So this one I can use as well. So in order to take that one, I can just do a pull, that one, and that will, now it will start fetching it from Docker Hub. So it will be finished. And I can also say, I mean, this one comes in two flavors. This is very common. First, you have one, which is the default. It isn't like a normal Linux distribution. And then it comes many times with the Alpine. So Alpine is a minimal Linux distribution, so to say. It provides a few Docker base images which are really small, and they're using muscle C instead of glibc. It can lead to some troubles if you're trying to build an application in your container, but it's very common to use that. You will see that a lot on Docker Hub. So we can pull down Alpine version as well of the same stuff, and we can compare. So let's see what happens here. So now I'm pulling down both of these, and we can compare with the ones I created. So if I do Docker images here, I can see here that my app container, the one which doesn't contain systemd, is uncompressed 77 megabyte. The systemd container 96. And then the Alpine version, the official one, is 107. And then the HTTP with, I think it's Debian in the bottom, is 166. Much bigger than the others. Of course, you can't really compare the ones I built with Yocto with these ones, because we might not have used the same compilation flags. I might have more things in my container, it can be different version, etc. But it still gives a hint that you can reduce the size if you know what you need and know what you want. But just like changing from the standard one to Alpine reduces the size a lot. And I mean, footprint is not very important for some people. If you're working in a data center, Google or Amazon or whatever, you don't care if it's 100 meg or 300 megs. But if you are at the edge, if you're building in kind of an edge solution, or I should say the embedded solution, a base station, something which doesn't have too much memory, and each container, if you can reduce the size of each container by 2x, 100% or 50% less, I mean, that can mean a lot to you, because you don't need to have that many disks. You can really reduce the network traffic because you need to update these images. And there are a lot of benefits of that. And then there are also security, and I can come to that as well later. So we can just, if you want to look at these, the difference between these. 1 second, I will just see if I like that. I can create the directory called WinRiver app here. No, I must write. I do app files. And if I do export on my Docker, I can see what my container contains, so to say, what the root file system contains. The same way I can take, I can create a directory for my Docker Hub, one for Alpine as well, and then so now I'm just exporting what I have. I could, what did I call it? I haven't created one of those containers. Let me run a container which I pull down as well. This is the standard, the latest. And then I will run the Alpine as run. If I do Docker ps now, I have 4 containers running. Okay. If I do inspect on, let's see, I should do inspect. Can you do? I call it dhub Alpine, for instance. It has address 05, just to prove that it's running. It is running, right? Okay, so if I then export, I export out my root file system, which is running right now. And then I do the same with Alpine. If I go into the Wind River container now, the Yocto container, I should say instead. Wrong command. I'm doing copy paste error sometimes. So this command will just show the files which takes most of disk. So you see in my container, the Yocto container, is libcrypto that takes most space, DNS, knutils, and then down here, Vim here. Vim maybe is not something I need. That maybe I should remove from my container. OpenSSL, and here comes HTTPD, right? So here you can see the sizes. If I go to the Alpine container, for instance, I can do the same. Of course, I can do like that. I can do the same. You see, of course, there's another set of files. This one had MariaDB installed as well, the database. Maybe you need that in your container, in your HTTPD. Maybe you don't. And Perl, I guess, is required for that as well. Then comes libcrypto as number 4. So you see here, there's a different set in all these containers depending on how it was created. And even if I go to Docker Hub, the standard one, what was the name? This one, it will probably show up with something else. Yeah, it had another top list here of the most takes most disk. libcrypto is here, HTTPD here, and so there are different settings here. The benefits, if you're used to Yocto, you know how, I assume you are a little bit used to it at least, then you know that you can actually see how your stuff is, how it is set up beforehand. So if I go, for instance, here, let's see, if I go to temp, see here, temp work, go to my app container, and I go to temp directory, and I do log, like that. This is my log for my build when I built my app container, when I actually created the root file system for it. Okay. Go down in this file. You can see here about the packages that are packaged in my container. And you can see a patch here, the size of it. You can see other dependencies that have been installed that was required according to my system. And I think in some of this stuff I don't need actually. So I could actually add to my Yocto build to remove this stuff. So I have an option here to remove as much as possible. And a big reason why you want to have a small container with low footprint. First of all, as I said before, disk and all these kind of things. That's one thing. Another thing is security. The more packages you build into your container, the more vulnerable your container will be. So I was at the Embedded Linux conference last year, and it was a really great talk from one of these guys working a lot in the data center. So they could show how many CVEs or vulnerabilities you can find in normal base containers that you can find, for instance, on Docker Hub, and that people just run and put their applications on top. And they showed that if you pick a smaller base container, the more vulnerabilities you get. Even a vulnerability in a package you don't need can expose your entire container. So containers should only contain exactly what you need. So with Yocto, you have the option beforehand to set everything, right? You define exactly what your container defines. The other approach is going through taking a base container from the web, which also works fine, like Alpine or Debian or whatever. You take that one, you add your application on top, and then you try to remove things by hand or by script or whatever you want. Maybe you write a Docker file, and you remove stuff from that complete package, and suddenly you have something which you think is fine, right? So it's depending on how do you want to buy. For instance, if you buy a car, do you want to write your specs, send it to the car manufacturer, they create the car that is perfect for you? Or do you want to buy the ready-made car? You come to the dealership, you say, I want the red car instead. They repaint it. You want more seats. Maybe you want whatever you want. These are different ways of looking at the same problem, so to say. And also, as you know, with Yocto and WinRiver Linux, is that you have all these other features, such as the licenses manifest, for instance. In the licenses directory, you find all the licenses for your build. You can find also for base images, you find that people have created this license manifest for you. But at the same time as you remove a package or add a package to your base image, that information is no longer correct. With this kind of build, you have full control of your system, and you know exactly when you make a change, this directory will change and everything will change for you. Any comments or questions? Okay, I will do one more thing here. I've done system containers. I have done app containers using WinRiver Linux as well. And then I will also do this. I will show you OverC. So OverC is a feature developed by one of our maintainers at WinRiver. It's open source in Yocto. Anyone can use it. What it is, it's basically a containerized operating system, or it containerizes your operating system, I would say. So the idea is that instead of having a kind of a big image as having the entire WinRiver Linux image, you containerize it. So you have a support for x86 and ARM, and then you have your kernel, and then we have a container called Kube Essential. Kube Essential is the bare minimal to get the system up. Nothing else, nothing more. It only supports a very simple container engine, and that's called pflask. It's very minimal compared to others. And that minimal container engine brings up the Kube DOM0 container and the Kube VRF container. Just these two using pflask. And then this Kube DOM, which is basically what you normally would have in your operating system, all the nice features that you have with whatever. And what is included there is also a more capable container engine, runC, which is also used at the bottom of Docker runtime, such as the Docker runtime, and runC is used by many others, container engines as well, container runtimes, I should say, for engines. I confuse myself now. So runC is used in the bottom, and it's used in many other container engines. And they bring up then this Kube DOM. From Kube DOM, then you bring up other containers, such as Kube Server, and what other containers you need, like app containers or system containers. And this OverC system also supports either hierarchical containers or equal containers, like parallel. So you can make sure that one container does not kill another container if it would crash. Of course, if you would crash the kernel, you're screwed. But you can also control in this system which syscalls a container is allowed to do. So to show you how to build, I will not show you how to build OVC, but I will show you how to build, but I will not show you when I build OVC. So OVC just requires you to do a setup in WinRiver Linux like this, and there's a new distribution then called WinRiver Linux OVC. And the machine here is generic x86-64. You do like this, and you will set up your environment to build a OVC system. And as I showed you in the picture, we need a few containers. It's just not one. It's actually multiple. And if I just do the normal things you do with when you build, you set up or you add your environment variable, you add your OE environment, you do like that. And then it's just to run the big bake commands to run the container to copy paste, of course. Then you just run your bitbake command. I will not run this now, but you see, I'm building a cube VRF, a cube DOM0, cube essential, cube server, cube builder, etc. In my example, I'm using cube server. That's a non-graphical environment. I could build a cube desktop if I wanted to, if I wanted some graphical with a nice, you can use XEMAX or whatever. But I'm not using that right now. What you will get when you build this is that you will get these containers, and they will be located in your images directory. So you see here, they are quite big, 269, 300, but you see the essential, the bare essential is just 69 megs. That's the only thing you need to get the system up and running. And then this one brings up the other. And you can set which order it brings up, and access restrictions between the containers, etc. So all of these containers now, we are creating one image. It's statically set, right? Not static as you can't change it, because you can change it in your setup files. But this image will contain all these containers. So when you boot that system, you don't even need network access to get these containers up and running. They will be in the image already. So I have this image, and I will now launch it. Or do you have any question why I'm launching this?
Maybe I have one question, Alan from Metoclover Ericsson company. Just one question. This video or your slides presentation, can we get that? Because I noticed that you are recording this, or maybe this is just for yourself.
No, so the recording will be available, and I can send you the slides afterwards if you want.
Okay, thank you. Because of all these long commands you're typing in terminal, we cannot remember. It's just in my head. So yeah, okay, thank you.
Yeah, I can send you the commands that I have as a reference on my side here as well. Can be good to know, to have.
Yeah, thanks.
So now I will start my image, and I will use Symix, eat your own dog food, as people say sometimes. So Symix is a product that we have, so why not use it? So I'm running the QSP, WinRiver's Symix QSP. That's a quick start platform. I will enable my network. No. Then I will start the simulation. So I remove the Symix window for now, and you will just see the graphical view. So now we see the BIOS booting. And then you will see OVC grub here coming up. I can bring up the other console. I have two consoles, one graphical and one serial console. And now Essential is booting. And when that's booted, you can say that the operating system is up, but it's actually a very small part of the platform. Now it will start the other control containers as well. So essentially it's up, and now it's starting DOM 0. DOM has some IP settings here, but also it getting the IP settings from the VNF, or the virtual container. I can show you in the background here. So you have the Cube VRF, which has a virtual switch, which sets up the networking for the other containers. And in our case, actually, Cube server, which I'm running, will be the net prime, meaning that one will have the physical access to the Ethernet. So this picture is not correct, really. This physical Ethernet port from my machine will be connected to Cube server. Okay. Again, system is booted. I log in. So now I am in the Cube server. I can move around. So this is a setting that I have in my image, that I can move around from the TTIs, doing Alt, F1, F2, etc. I can move around in my cubes. This is just a setting that I have to have it easy to install. This is not something you would have in your production if you would do this in the production. So here is Cube Essential. It is up and running, and then we have DOM 0. Right now, I think my simulation is going a bit too fast. If you see me writing date here, you see the seconds are moving really fast. So I have to tell Simex to slow down because it's running too fast right now. Now it will slow down. Yes, it slowed down. So I write C3 list. I get the list of the containers running in my system. And you see here, net prime. So currently, Cube server is my primary interface. It also has this IP address, it's lowest. And there is a command server, as you see here in the background. So I can actually connect to others. If I want to connect here from DOM 0 to Cube server, I can do that through internal what's called links or communication channels. So we actually open up holes so you can poke through the containers into another, and you can disable and enable this, of course. So now I moved from one container to another using the command server. I can go out again if I want to. And then I can set up everything here. I mean, now I'm running oversee commands. You're probably not used to them, probably used to Docker or something else. But the thing is, you also can instantiate the Cube Docker container if you want to. If you're more familiar with Docker and want to bring up Docker containers on top of this system, that would be in a separate container. So these Cube commands are just for doing simple things, and sometimes you can do even advanced things, as I said before, controlling which syscalls a container can do, which access you have, etc. And the benefit of having this kind of containerized system is that you can actually replace containers as you go. So this DOM 0 here, which is pretty much what you would normally have in an operating system, you can replace that at runtime. Even though the Cube server is running, I can replace Cube DOM 0, replacing the run C with a new run C runtime version, and the other containers will still running, and then update the system. So I will update the system more live. I can roll back containers. I have a lot of more options in this kind of system. This is a very interesting technique to have a system which supports container, and they are kind of static, but at the same time you can bring in dynamic containers. So Kubernetes, for instance, can be connected to this system and control the other containers you need. So what I have not planned to show you anything more today. I showed you now the features, some features you have in WinRiver Linux and Yocto, how you can build containers, how you can build a containerized operating system out of Yocto. And if you have, maybe you have some questions. I don't see anything on the chat. No questions. So I might have gone a little bit too fast. So I will send out my notes to anyone who needs them. You can write down my email address here, thomas.holmberg@windriver.com. So I know who wants this information, and I can send them to you. And next webinar session, I will talk about WinRiver Linux and security. When I talk about WinRiver Linux, it's of course Yocto as well, but I will focus on our distribution of it, WinRiver Linux. So next week, WinRiver Linux and security. Thank you very much.
Thanks.
Thank you, Thomas.
Thank you, Thomas.
Thank you.